Holy smokes, I can't believe it's time to start another school year, but it is officially time to rock and roll. So let me be the first to welcome you to Common Core Algebra 2 and our first video of the year with our flipped classroom. A flipped classroom is going to be drastically different than what you've experienced in the past. Over the next couple of weeks, we're going to continuously give you new tips that are going to help you be successful in this new environment. Be patient. It's not going to, come automatically. It's going to take some getting used to at times. But tonight, I want to go over the 3 big keys that I think are going to really build your success throughout the year. And the first one is pacing. One of the quotes that I like to say all the time is take control of your own learning. Only you know how many times you're going to have to hit the pause button, but that's one of the great features here is you're going to be able to stop the lesson at any point you want, and then sometimes besides hitting pause, you want to rewind it and listen to what we said, a second or a third time. And again, these videos are going to be up all year long, so if there's one topic that's continuously giving you trouble, you can always come back and rewatch it a month or two later. Number 2, and this is sometimes the toughest one where it really takes a lot of self-discipline, but we've got to eliminate distractions, okay? So if you're doing this at home in your bedroom, sometimes we just got to, we got to turn the TV off, and sometimes we got to really, set the cell phone down and just block out all the text messages and get off Twitter, and I know that's easier said than done, but we need to really eliminate distractions. And number 3, we want to encourage you to do it. It's an individual activity. This is not a team effort right now. We're going to do a lot of group activities in class, but right now, as far as watching the lesson each night, that's really something that we want to encourage you to do by yourself. Really, get isolated, focus in, and lock in. Again, this is going to be something that we're going to continuously get better at throughout the year, but what does a great notebook look like? So a couple of keys here tonight. We always want to start off each night with the date and the title. And what that's going to help us do, again, as we get later into the year, whether it's December, January, or even June, when we want to go back and look up an old title, if we've got everything dated, we're going to be able to find it a lot easier. Number 2, we want it to be very neat and legible. We want it to be something that you can use as a resource down the road. And of course, these notebooks don't help if we can't read what we wrote, or if we're getting sloppy and all of a sudden our equal signs look like negative signs and vice versa and stuff. Number 3, I'll encourage you, use color. Not a ton. You don't want to color everything, but I think, as you can see in this notebook here, a little dab of color here and there, and especially this little asterisk and note right there, use some color, whether it's highlighters, colored pencils, markers, whatever it is that helps you organize your thoughts and make key things stand out. Just a few more tips here before we dive into our first lesson. And I want to talk about some strategies for kicking butt in math. And number 1 is we want to talk about the difference between active studying versus passive studying. And of course, we want you to become active studiers. And this could be anything from, asking great questions in class. And I'm always going to tell you, don't swallow that question. Bring it up in class tomorrow. Or active studying might be, coming and getting help during your free periods. But most of all, I think active studying is when you're watching the video, how active are you? Are you trying the problems ahead of time before I go ahead and work them out? Or are you just kind of cruising, coasting, and letting me do all the work, and you're just kind of copying it down without really being engaged? So I really want to encourage you to get active. And number 2, studying math is so much different than studying other subjects. And our big key idea is that we're going to learn by doing. And we're going to really, we're going to dive into these problems, and we're going to roll up our sleeves and get our hands dirty a little bit. But the more problems we can do, the better we're going to get. So here we go. Tighten up those bootstraps. We're going to dive into our first lesson. Our title today is Solving Linear Equations. So we'll go ahead and get that title at the top of your notebook with the date. And we got 2 big goals today. We're going to try to solve linear equations that might look something like 2x plus 5 equals 6x minus 4 times the quantity x minus 2. And again, we're just going to try to solve for x. And then we're also going to try to build a real strong vocabulary. We're going to be able to describe and justify each step using great sound mathematical vocabulary. All right, we're going to go ahead and get our vocabulary out of the way first, and this is really going to help us throughout the entire year. It's really good to identify some of these terms that we take for granted just to make sure we're all on the same page, and I think it's going to eliminate a lot of frustration throughout the year. Also, I'm going to buzz through these fairly fast, so a good time to hit that pause button if I'm going too fast and really get great details and get the full definition in there. So first of all, what in the world is a variable? A variable is a quantity that is represented by a letter or a symbol. Okay. Now a letter is usually, we use like the letter X. I'll put that in parentheses there, or a symbol. Now we're going to use, sometimes we use Greek letters and so forth. One of the symbols we'll use later is the theta symbol. That is unknown, unspecified, or can change within the context of the problem. Okay. Next definition. What is a term? Mathematically speaking, it's a single number or combination of numbers and variables. Numbers and variables using exclusively multiplication and division. Examples there, something like 6x is a term, or something like 5x squared y squared. That's also a single term because we're using exclusively multiplication right there. Or maybe 5x divided by 3. Again, we're using exclusively multiplication here, division here, so it's a single term. Expression is a combination of terms using addition or subtraction. So something like 7x plus 2 is an expression. Now this happens to have two terms. 7x is a term, 2 is a term, so we call that a binomial. You probably remember that from Algebra 1. Or something like x squared plus 5x minus 3. Now we're looking at three terms separated by the plus sign or the minus sign, and now we call that a trinomial. So again, that's probably a review from algebra. Our last definition for tonight is like terms. Like terms are two or more terms that have the same variable raised to the same what? Raised to the same power or same exponent. We could use the word exponent instead of power if you want. Now when we talk about like terms, only the coefficients can differ, and I'll talk about that a little bit more in detail here. Only the coefficients can differ. So let's take a look at two terms. 6x and 10x are considered like terms. They both got the same variable. Now they do have different coefficients, but that's okay. So they are still considered like terms. 5x squared y is considered a like term with 8x squared y. Again, same variables raised to the same powers. Their coefficients are different, but that's okay. Now if I made this y squared over here, now they wouldn't be like terms because the y's have different exponents. Here's our first example that we're going to use here, and in fact, we're just going to worry about the first three lines. I'm going to cross off these bottom three here. I'm not worried about them. But what we're going to do is we're going to try to simplify this linear expression right here, and we're going to state the real number property we just used each step along the way. So remember, our choices are commutative, associative, or the distributive property, and we're going to try to specify each one. Great chance here as you're writing down the problem to try to hit the pause button and try to fill in each of these first three blanks on your own to see how you're doing. For me, the first blank was the distributive property, because what you could see what they did is they took the 8 and they distributed it to the 2x and the 3. They also did the same thing with distributing this 5. Now the second property is not as obvious, but what happened was they changed the grouping, so I'm going to call it the associative property. You can notice how they moved there technically was an implied set of parentheses right there, and they moved the parentheses so it was around the 8 and the 2. The same thing could be said for that term. They moved the parentheses, so we're using the associative property. And then last but not least, you notice how they changed the order of some of the terms. Like, for instance, they took this 15x and they swapped it with the 24. And you can see how the order of these two terms changed. So now we're using the commutative property where we say, well, since we're adding, the order doesn't really matter and we're going to move those terms. Now what we're going to do is when we start to simplify these expressions, we may not show quite that many steps. We're going to speed it up a little bit, but in a nutshell, we want you to be able to identify and see each of these properties in action. Okay, a few more examples. The directions say we're going to state the number of terms in each expression, and again, try to buzz through these really quick on your own without me saying them ahead of time. So hit the pause button, try them. Okay, I had two terms here, and they were just, anytime you see a plus sign, they're separating terms. Let's see, I had 1, 2, 3, there's 4 terms, 1, 2, 3, 3 terms. And all I'm looking for is the plus signs or the minus signs, and that's what's going to separate my terms. Here we want to classify each of these expressions as either a monomial, meaning it has 1 term, a binomial, meaning it has 2 terms, or a trinomial, meaning it has 3 terms. Anything beyond 3 terms, whether it's 4, 5, 6, or 20 terms, we just classify it as a general polynomial. So in number 1, I'm seeing 3 terms, so I'm going to go ahead and call that one a trinomial. The second one, that's just 1 term, believe it or not, so that's a monomial. And the reason is we're using exclusively multiplication. There's no plus or minus sign, so it's just one gigantic term. Number 3 looks like I'm seeing 2 terms, so we'll call it a binomial. And let's see, I got to scooch down the page here a little bit. This here, we're using exclusively multiplication and division. Again, there's no plus signs, no minus signs, so it's a monomial. Okay, for our next set of problems, we're going to talk about simplifying each expression. Notice I'm not using the word equation yet because there's no equal sign in this problem, so we're just going to call it an expression. We're going to focus on combining like terms. I'm going to challenge you to buzz through them as fast as you can, and again, if you want to try them on your own without me, feel free to do so. I'm going to go ahead and distribute the 6, which is going to give me 12x minus 30. Then I'm going to distribute a negative 2, and I got just a little bear trap coming up here. That's going to be minus 16x. I'm going to say plus 20 because we're taking a negative 2, multiplying it by a negative 10 to get the positive 20. My like terms, I'm going to combine the 12x and negative 16x to give me a grand total of negative 4x. And then if I combine my negative 30 with my positive 20, I'm going to get negative 10. And that's as far as I can go because they're not like terms, so I can't combine those two rascals. Alright, my next example here, good news is there's no parentheses, so I don't have to do any distributing, but I just want to focus on my like terms. Let's see, I got a y cubed here, and I got a y cubed here. So those are like terms, and if I combine a negative 5 with a negative 8, that gives me a grand total of negative 13y cubed. So really, as I'm adding those terms, I'm combining the coefficients, but notice how the exponent stayed as a 3. Next term, I'm going to use a different color. Do you see any other y squared x's? I don't anywhere else in the problem. So I'm just going to bring 6y squared x down just because he didn't have any friends to combine with, I guess, in this problem. And then last but not least, I see, let's see, 4yx squared. And then I got a negative 10yx squared here. So those are like terms, same variable with the same powers, respectively. Combine a positive 4 with a negative 10. That's a grand total of negative 6yx squared. And that's my final answer. Okay, now they finally have given us an equation here. This is the first time we've seen an equal sign, and we're going to talk about solving for x. And the key here to this first equation is, and you want to be able, and maybe comment on this in your notebook, is we want to get all the x's on one side. So I'm going to subtract 6x from both sides. And that's going to give me 4x minus 3 equals 21. Now I'm going to add 3 to both sides. That's going to give me 4x equals 24. Divide both sides by 4, and bada bing, bada boom, x equals 6 is my final answer. And of course, anytime you're feeling unsure, we could take that 6 and plug it back in to the original x's. And by substituting it back in, we're going to be able to verify that we do indeed have the correct answer. For our next example, I'm going to use one of my favorite shortcuts, and you can notice I had to scribble out this first problem here. I couldn't figure out how to erase it on this program yet, but I'll work on that. But anyway, so I want to focus on this problem right here. I'm going to use what's called the distributive property of division to simplify this fraction right here. So I'm going to rewrite it as 4x divided by 2 minus 10 divided by 2. And again, all I'm doing there is I'm taking one big fraction and I'm decomposing it into two smaller ones. Now, if I simplify that first fraction, 4 divided by 2 is 2x. 10 divided by 2 is a 5. Now from here, we're really coasting. We're going to just add 5 to both sides. 2x equals 12. Divide both sides by 2, and x equals 6. Again, ironically. Now we're buzzing right along here. We've got a lot of content in tonight's lesson. There's no doubt about that. So now I want to address a couple of weird things that might happen once in a blue moon. Number one, sometimes we get no solutions. You're like, wait a minute, is that possible? Well, once in a blue moon, we'll get no solutions. And in this case, we say the equation is known as inconsistent. That's the terminology we're going to use. So if there's no solutions, we're going to label that equation as inconsistent. Now the other rare oddity is other times any value of x will solve the equation. So now this is the polar opposite. Instead of saying there's no solutions, we've got an infinite number of solutions. I'll put the little infinity sign there. In which case, this equation is known as an identity. So if there's an infinite amount of solutions, we're going to label that equation as an identity. So let's go take a look at a couple. So basically, we're going to work on solving these equations just like we normally would, but at the end of the day, we're going to try to classify them as either an identity, meaning there's an infinite number of solutions, or we're going to label them as inconsistent, being there's none, no solutions whatsoever. Okay, again, I'm going to challenge you. Feel free to do these on your own if you'd like. If you're not feeling as confident, you could stay with me here and listen to my commentary along the way. But I'm going to go ahead and I'm going to use the distributive property here right off the bat. And I'm going to be really careful to watch my signs, make sure I've got negatives when I should. We'll distribute the 5. So we got 5x minus 5 plus x. Now I'm just going to focus on cleaning up each side respectively. So on the left side, combine like terms, I'm going to get 6x minus 6. And then when I focus on the other side of the equation, I'm going to combine like terms to get 6x minus 5. Here's where something weird happens. We talked earlier about how we want to get all the x's on one side. I'm going to subtract 6x from both sides. Something really weird's about to happen. Negative 6 equals, whoops, look at all of these x's cancel out. Now take a step back and ask yourself, is this true? Does negative 6 equal negative 5? And I'm going to say, no way, Jose. It's not true at all. And because there's no solution, we'll abbreviate just a little bit there, we're going to say that this equation is inconsistent. Inconsistent. No solution. Okay, and last but not least, we got one more equation here. I'm going to go ahead and use the distributive property for multiplication right here. And I got 2x plus 1 plus 2x minus 2. And then I'm going to, on the other side here, I'm going to use the distributive property for division. 16x divided by 4 minus 4 divided by 4. Alright, combine like terms on the left side here, put brackets around it. So I get 4x minus 1 equals, let's see, divide those two. I'm going to get 4x. Whoops, I caught my little mistake there. 4 divided by 4 is 1. Okay, check this out. Notice how the left side is exactly the same as the right side. Watch what happens. If I subtract 4x from both sides, let's see, I got negative 1 equals negative 1. So this is completely the opposite of what we just had. This is true no matter what. And so we're going to say that there's an infinite number of solutions, which means this equation is labeled as an identity. Okay? So I hope you got everything taken care of tonight. We'll dive into some group work tomorrow. There'll be a combination of working in groups and working by yourself, so you have a chance to kind of show off and showcase your skills. Have a great night. We'll see you in class tomorrow.